Okay, let's have a look about these two topics. One is permutation and combination, and the second one about the probability. Okay, in usual, probability were related to permutation or combination. So let's see. Now first, about permutation. What is permutation? Do you remember? Here in PR, that means we have the number of permutation of R subjects choosing from n different objects. Okay, that means now here we have, for example, 1 2 3 4 5 6 7 items. Then you choose maybe some of them, maybe all of them, to have the permutation. Okay, so for example here, if now we have 7 things, 7 items, right? Then if we choose all to put it in a row, that means what? That means now here n and r also equals to same values. That means 7 different objects, and then we choose all of them 7. So this one 7 factorial and then over 7 minus 7 factorial, that means 0 factorial, that means 1. So 7 factorial. That means if we choose all of them, okay, and then find different order, that means the permutation. So 7 factorial. Okay. Then how about if we choose something here as an example? Same as above, we have 7 objects, okay, different objects. Then we choose 3 only. Okay, that means pick up 1, 2, 3, maybe A, C, E, okay. Then maybe B, D, G, okay, maybe F, C, A, okay. Whatever we choose 3 objects, okay. Then with the order, that means if we choose A, C, E, then we still have different orders. So according to this one, so 7 items and then choose 3, okay. So this one is 7P3, okay, 7P3, okay. This one is only ACE, maybe ABG, ABF, okay. So plenty of number of ways. So this one, permutation. Remember permutation with the order, okay. Let's see, combination, okay. In Chinese, for these two words, do you remember? One is this, 排列. One is this, combination, 组合. So if you understand these two words, then you know the differences between these two words, okay? So the meanings of combination here, the number of combination of R objects choosing from n different objects. Okay, so this one is NCR. So here, when n, where n and r are positive integers, n are in between 1 to n. Same as we have 7 objects. If we choose 7 as a group, okay, that means combination. So this one is 7C7. You found that if you choose all of them, that means you only have one combination, right? So 7 factorial over 7 minus 7 factorial and then over 7 factorial. And here equals 1, 7 factorial over 7 factorial, that means 1. So you only have one combination because no order for combination, okay? So all of them you choose, that means only one, okay, one group. How about this one? This one, that means 7 items, choose 3, so 7C3 without any order. So if you choose here A, C, E, that means this one. This one is one of the combination. Here we have 7 different items. Maybe you say that, okay, ABG, ABF, ABE, ABD, okay. If you count it, so you can use your calculator to find out 7C3, okay. The value of 7C3, then you can use your calculator to find it, okay. So hope you understand. For P permutation, that means with order, okay. For C combination, that means without order. Okay, so when you study the question, you need to understand whether the question asking about the permutation or combination. Okay, let's see about permutation first. Okay, here actually you can refer to your notes if you have, or just study this question now. 6 children from P to U, PQR, STU, okay, sit on the same row. Question A, if now PQR sits next to each other, so this is the condition, okay, and say that how many permutations are there for sitting arrangement of these 6 children. This one tells you that you need to find this permutation, so no need to think, you just find out the permutation. So you understand the meanings of sit next to each other, right? So if you understand, then let's see. Okay, that means now you have this situation. P, Q, R sit next to each other. So I maybe group it as one item. So this one as a group. So you have 1, 2, 3, 4 items, 4 different items. So how to get it? Permutation, that means with the order, so you see that it's 4p4. Okay, so 4 factorial. Okay, so you think that, okay, maybe this one as a group, right? So this one, and then S, T, U, right? Okay, maybe S and then this group, because they need to sit next to each other. So like this, okay, maybe this one, okay, S and then UT, right? More and more, then you found that you are very difficult to find out all by write down all of them. So remember this one, that means 4 factorial. Okay, okay. So besides this one, STU and this group can have this permutation 4 factorial. PQR also can rearrange it. Okay, so here we have 3 factorial in this group. Okay, because 3 items inside this group. So at the end, what is the number of permutation? You see that this one, the number of permutation is 4 factorial times 3 factorial. So this is the number of permutation for the question A. Okay, how about question B? Let's see. Now here, if P, Q, R this time sit next to each other, so do the another 3. So this time you not only have PQR, okay, remember STU also group as a group. Okay, so here 1 group, 2 group, you can think it as 2 items, so 2 factorial at the beginning, and each group you have 3 items inside, so 3 factorial for this one and 3 factorial for this one. So at the end, the number of permutation will become this one. 2 factorial, that means this one. Okay, and then 3 for the first group and then 3 factorial for the second group. So times all together, it will become 72. Okay, okay. How about the last one here? Let's see. Now if PQ sit next to each other, RS also, so do TQ, T and U. So how many again permutation are there for the seating arrangement for these 6 children? Maybe you think, oh, this time I know, because this as a group, okay, this as a second group, and this one as a third group. Okay, right? If you know that this time we think it as this three groups, you can study it as 3 items. So the number of permutation will equals to, okay, here 3 factorial, right? 1, 2, 3. You can think it like this: 1, 2, 3. So 3p3, you see that's 3 factorial. And each group you have 2 items. So here 2 factorials times 2 factorial times 2 factorial. So finally, what is the answer for this one? You see that this one is 48. So see, when you understand the question and ask the question asks you about the permutation, you just think it, okay, if you need to arrange it in a row like this, then how many items? Okay, if total is 6, then 6 factorial. However, sometimes we'll have some condition, then according to the condition, maybe each here we have 2 different groups because they want to sit next to each other. Then you can think it as 2 different items, then 2 factorial, and each item inside have 3 members, so you can take 3 factorial. Okay, so times all together, you get the number of permutation. Understand? Now let's have a look one more example like this. Okay, how about this one? Again, 5 students A, B, C, D, E are arranged in a row. Okay, this time arranged in a row. How many permutations are there for the 5 students? Okay, no condition. Okay, just arrange this 5 students. So easy. Total 5, that means 5 factorial. So number of permutations 120. Right. Now part B. A, B are arranged next to each other. So this time you need to think it as one group. Right. Then again, question asking about the permutation. No need to think. So here, after you group AB, 4 factorial, right? Okay, maybe I use a blue color. Here we have 4 factorial, 1, 2, 3, 4, right? And inside this group, 2 factorial, right? So as a result, the number of permutation 4 factorial times 2 factorial, so it's 48. Okay, how about part C? Now here A, B, okay, this time not arranged next to each other. Okay, then how to do it? You see that just now part A, all permutation of this 5 students. So this is a total number of permutation. And parts B, A, B sit next to each other, right? Arrange next to each other. So this is the number of permutation that A, B arranged next to each other. So what do you think part C? What do you think part C? Yeah, correct. It's related to A and B, right? And you found that this one actually 5 factorial minus 4 factorial times 2 factorial. That is answer of part A minus answer of part B. Because if they are not arranged next to each other, that means cross out all this 48 situation, 48 ways. So you see that 120 minus 48, and this one is the number of permutation, 72. Okay. Besides this method, I want you to have a look the alternate method. This method is quite easy to understand. So let's have a look. Now here, if A, B not arranged next to each other, that means let's see. You have C, D, and E, right? C, D, E, that means here we can arrange. Okay, maybe C, D, E. Okay, so C, D, and E, C, D, and E can arrange in this 3 position. And how about AB? How about AB? Oh, yeah. You found that AB, maybe you can put it here, okay, or here, or here, or here. This 4 position can put A or B, okay? That means you have 4 choices and choose 2 position. Maybe this 2, A, B, maybe this 2, A, B, okay. So A, B, B, A, 2 different choices. So you see that this one, actually, you can think it as 4P2. 4 position, you choose 2 of them for A and B. So for this one, okay, this one is 4P2. How about above? C, D, and E. Because C, D, E, you need to put it in this 3 position. That means 3 choices, okay, maybe 3 different items. You need to put it in this 3 position. So 3P3. What is the 3P3? That means 3 factorial. Okay? So finally, you can think it as 3 factorial times 4P2. Then you get it. It's 72 also. See? You can use this one, or by this method, think it like this. 3P3, because put it in this 3 position for CDE. And for AB, you need to not arrange next to each other. So this 4 position can put it in for A and B. So choose 2 position for AB from these 4 choices. Okay? Understand? So about the permutation like this, let's see about the combination. Now, here, let's see. If there are 8 S5 students, okay, and 5 S6 students, 8 S5 and then 5 S6 students, okay. 5 of them are chosen, okay, 5 of them are chosen to form a team for a competition, okay. So, let's see. And if a team must have at least 2 S6 students, okay, how many ways are there to form the team? And you found that this one, 5 of them to group as a, to form as a team. So because question haven't told you, you need to choose a chairman, a vice chairman, or whatever other position, treasurer, okay. No, that means no need to think about permutation. If we have this one, then you need to think about the permutation. However, this time, no, just choose 5 of them to form a team. So no need to think about this time. This time, no need to think about this. Okay? Okay? That means you just find the combination only. Okay? Find the combination. Okay? So, can you think about this? They can bring it down how many cases, okay, if at least 2 S6 students. Okay, at least 2 S6 students. So, maybe you can pause and then think about this one, and now I will let you know. If you have at least 2 S6 students, that means maybe having 2 S6 students and then 3 S5 students, because total 5 for this team. If you choose 3 S6 students, then you just can choose 2 S5, right? If you choose 4 S6 students, then you only can choose 1 S5, okay? Or all of them, 5 of them, S6 students, okay? And remember, how many S6 students are there? For S6, there are 5 S6. Okay, and for S5 there are 8 S5. Okay, there are 8 S5. So how to do it? Okay, for the first one, that means you need to think from 5 S6 to choose 2. That means 5C2, right? From 8 S5 to choose 3. So 8C3. Okay? Okay? No need to think about the position. Okay? So C. 5C2 and the 8C3 for this combination. Okay? This is the first case. So 4 cases, you need to think about that. How about the second one? From 5 of them to choose 3. So 5C3. From 8S5 to choose 2. So 8C2, right? I think you know about the third case and the fourth case, right? This one, 5 to choose 4, and then 8 to choose 1. And finally, choose all of them, 5C5. So the total number of ways to form a team, you can write down all of them. So this one, the first one, or, okay, second one, or, the third one, or the last one. Okay, because either this one, or this one, or this one, or this one. So you see, or you just add up this 4 different combinations. So finally, 881. Clear? Clear? Okay, let's see. One more example. Here, 5.4G. There are 14 boys and 6 girls in a mathematics club. Okay. Then, part A. How many ways are there to select 3 students to be club representative? Okay. Just think it as club representative to select 3 of them. Okay. Any condition? Seems not right. So, how many total students are there? 14 boys and 6 girls. So, total 20. Right. So, what is the number of ways? How many ways? Just have this word ways. That means P, permutation, or C, combination. Okay. Maybe you can find from part B, because part B seems like the same question, but to be the chairperson, vice chairperson, and secretary. That means you have the position. So this one, no position, then you think it should be combination, right? So C, let's have a look. Total 20 of them, and you choose 3 of them only. So the answer 1140. Clear? But part B, because you need to choose number of ways to be different position. Okay? You have different positions here, right? So the number of ways, that means P, 20P3, 6,840. Okay? For example, you have choose A, B, and then G. Okay? So A, B, G, this 3 student, you can chairperson, vice chairperson, and secretary. You can BAG, okay? You can BGA, you can AGB, and then dot. Okay, that's enough. You can think because you have a position, so use P. Like the different order with the same combination. All of them are ABG, but you need to think about the permutation. That means put it in order. Will have different ways. Last one. How many ways are there to select 3 students against 3 students to be club representative, given that at least one of them is a girl? Oh, at least one of them is a girl. That means you need to think. Maybe M, F, at least one. That means this is a case 1. Maybe 2 girls. Case 2. maybe all of them girls, right? Right. So how to do this one? Yeah, just like the above, right? If MMF, that means 14 boys, you need to choose 2, and then 6 girls, you choose 1, right? Okay. Or 14 boys, you choose 1, and then 6 girls, you choose 2. Or the last one, 6 girls, you choose 3, all of them. Okay, that means 3 of them are girls. And you see that this one is 776. Okay, 76. However, maybe you can think it like this. We can use, okay, another method. All choice, okay, all the number of ways, 20, C3, okay, and you cross out all boys, that means 14, C3. You still can get the same result, 77, 776, 776. Clear? Okay. So after you understand the permutation, combination, then we can have a look some probability question. Okay. Then what is the probability question? Later, maybe have a look one more about the password. Okay, password question. Let's see. Now here there are 26 letters and 10 numbers to choose from. Now to choose 6 different letters, okay, and then 2 different numbers. How many combinations are there? So this time not difficult because 26 letters to choose 6, and then 10 digits to choose 2. So overall, okay, use your calculator to help you. Here is the answer. Okay, 10,360,350. This the number of combination. Next, part B. To choose 6 different letters, 2 same as, okay, 2 different numbers. How many 8-digit password can be formed? Okay. How to think it? Okay. Just now we have the combination ready, right? That means for each combination, you can put it in different order. Okay. That means you choose that 8 letter and numbers. You see that number of permutation for 8 digit in the password. That means 8P8. That means 8 factorial, right? Right. So for each combination, you have 8 factorial permutation. But now, do you know the combination? Yeah, part A is the answer of the total number of combination. Each of them times 8 factorial. So you found that this one is really great. 4.18 times 10 to the power 11. Okay. And correct to 3 significant figures. Okay, 3 significant figures. That means 418 here. Okay, understand? Hope you understand about the combination and permutation. This question actually is a kind of question related to 2, that means both of them, permutation and combination. Now, let's have a look some probability question. Probability question. Let's see. Here there are 30 students in 5A, 28 in 5B, and 24 in 5C. If, okay, 2 students are selected randomly, find the probability. Okay, now remember, if the question told you that about the probabilities, that means your answer should in between 0 and 1. Okay? Just now, all of them are the combination and permutation question. So you see a great value, okay, very large value, maybe up to 1,000 or up to 100 or million, okay. But now, probability question. So remember, you need to think about the probability. That means you need to think the total number of outcomes, okay, and favorable outcomes. Let's see. A. 2 students from the same class are selected. Okay, 2 students from the same class. Okay, how to think it? How to think? So let's see. If they comes from the same class, that means here, let's see. Number of combinations selected from 2 students from the same class. Okay, maybe it comes from 5A, so 30C2. Maybe it comes from 5B, so 28C2. Or from 5C, 24 from C2. So this one, or this one, or this one. That means from A or B or C class. So after that, you get this 3 value add up together to get the number of combination. This one is the favorable outcomes. Okay. Then what is the total number of combinations select 2 students? Do you understand? Yeah, that means comes from all 3 classes. And you see that, oh, that means here, total number of students, you choose 2 only. So 82C2 as the total number of combination. This one as the total number, total possible outcomes. Okay, total possible outcomes. So you see that here, let's enlarge it, and you can get it. Probability, 2 students from the same class. So this one, 1089, and over total 3,321. Okay, so as a result, this is the answer, 121 over 369. Maybe sometimes you can write it directly if you understand probability clearly. So for example here, favorable outcomes, 30C2 plus 28C2 plus 24C2 over total number combination, 82C2, right? So you can get this one, okay? Maybe you think, oh, can I use the fraction to find out this one a little bit easy? So you can think, oh, AA, so 82 in total from class A, 30. After choose 1A, then 81 left, still from the class A, so 29. Or, so you see, plus class B, because 28, the first one, class B, the second one, 27, okay? How about class C or class C? So 82, and then C is 24. After take 1, left 81 student, and then class C, you left 23. So you can use this one, you can get the same result. But I prefer you use combination to find the probability. Okay, try to learn this one. Okay, part B, let's see. 2 students from different classes are selected, or different classes. How to do it? Maybe you think, just now we count about the same classes. Okay, same class. So if we know about all of them, if not same class, that means different class. So you found that, this one easy. 1 minus this one, some from the same class. So 1 minus 121 over 369. So this is the answer of part B. Okay, sometimes use the complement events, then you can find the answer easily. But not always, remember? Can we use this one, maybe count the number of combination? The answer is yes. Let's see. This one, let's have a look. From class A, okay, maybe I use another pen. Okay, this one is from a class A and a class B. Maybe you can use from a class A and class C. And the third one is a class B and a class C. Okay, from class AB, from class AC, or from class BC. Okay, because they are combination, so just choose AB, AC, BC, and then add up all together. From A, choose one. From B, choose one. From A, choose one. From C, choose one. And the last one, from B, choose one. From C, choose one. All together over, okay, this one just the same. Total number of combination, okay? You can get the same result. 248 over 369, like this. Clear? Okay? So let's hope you understand clearly about the probability, permutation, and combination. Coming, we'll have a look about some DSE question. So later to study from another movie.